So this question says that we have a man holding a weight in each hand and stands at the center of a frictionless rotating turntable. The effects of the weight are to double the rotation inertia of the system. So the person has a moment of inertia I. The person has a moment of inertia I, and the weights in each hand have a total moment of inertia of I as well. They both are spinning. They're both rotating, and at some point the man opens and drops the two weights. So if they're both spinning together, it looks like I have the I of the man plus the I of the weights. And they're both spinning together at initial angular velocity. Well, when we drop them, they're going to fall outside the turntable. So they're not going to land on the turntable, but they're going to fall outside of the turntable. We want to know what happens to the angular velocity of the man. So this is going to be the I of the man times omega final of the man plus whatever happened to the weights. And actually, when you write this down, the answer becomes, I'll substitute a final velocity of the man and final velocity, the angular velocity of the weights. So what happens on this is the person is spinning with their arms together, with their arms out with the weights in it. They have a weight in each hand, and they're spinning around. And then they drop these two weights. The problem is that these two weights, when they're dropped, they have some angular speed to them. They're rotating around, so they contribute to the moment of inertia it begins with. But at the end, they don't instantly stop and drop straight down. If you actually look above at them, at the weights above, if the person is spinning around, then these weights are going to be traveling in this direction. So when they let go, they still have an I omega. It's another form of this would be R times P, or R cross into P. They have a radius, they have some momentum. So that means they're going to have some angular momentum when they drop, and it happens to be exactly the same as the angular momentum that they begin with. So what actually happens if you do this experiment is you'll find that the angular velocity remains about the same. The person has angular momentum to begin with, the weights have angular momentum, the person maintains the same angular momentum, and the weights maintain the same angular momentum after they're dropped.